particular question's a little bit different than the ones we've seen before, but similar information. I need to solve for x. X is not a radius, it's not a diameter, it's a part of a radius, and we need to be able to find the length from the center to here. Go ahead, Taylor. You don't know that. Oh, I'm so sorry, you do know that. Sugar, yes you do, look at that. So you know that that's true. Okay, so you know that this length is 6, keep going.
So if the chord is bisected, then the length, or the bottom length is the triangle.
So that should be 3 over here, I agree. How does it help me find x though? Alex, you got some more information? Okay, hang on, let Alex, did you have, you sure? All right, let me see if somebody else knows. Dina, do you know? Where'd you get, 4 plus x? That is definitely one way to do it. So go ahead and say what you're going to say. 4 plus x. Uh-huh. Okay, I agree. That's one way to do it. There's an easier way. This absolutely would work. We could go ahead and multiply 4 plus x and get that binomial. You're going to get kind of an x squared. We'll end up with a quadratic equation. It becomes very complicated. Definitely one way to do it. Very algebraically challenging to solve this problem this way. Jared, you got a shorter way, easier way? Thank you. So we also know that this is 4 because it's a radius just like PB. So then we can just simply look at this little triangle here, and that would be a lot easier. So if this is 4, don't we know that, so this works, or we know that 3 squared plus x squared is equal to 4 squared. And that one's a little bit easier, okay? Both would work, but this one would be a lot quicker, don't you think? Okay. And then I'm not going to solve it for you, but I just wanted to kind of show you that we want to be looking. And by the way, you know, that would be really hard, but it would work. But this one down here would be a little bit quicker and easier. So we got to look for congruent segments, like Taylor showed me that it said AB and AC were congruent. We also know because Jared told us that all radii are congruent. A lot of information in this particular problem. Okay. I will tell you on the SOL, it is very unlikely that you will see something where you will have to do this algebra, okay? That is strictly an NYP thing in terms of, you know, the higher level algebra skills. Most likely you would have something that you could solve pretty easily, okay? That's good to know. All right, I do have some problems I'd like for you guys to work on before we get into the area of sector stuff. I am going to try to find some more note cards in case y'all don't have any. But I wanted to just kind of assess what you guys remember and what you guys don't know about angles and arcs. And when you finish this, we're going to move on into something new, which is area of sectors and arc length. Okay? So there's about 15 problems. It is going to be graded for accuracy. Kira's going to hand it out for you. And I'm going to come out of my shoe. That's interesting. Okay. This is not something you guys should work together on. This should be an individual assignment. You can work on, you can use your own notes. I would like it if you would show work, show me what you're subtracting, what you're adding, that kind of thing. And we're going to, especially when you look at the problems towards the, like problem number 3, for example. Does everybody have it? If you look at question number 3, we went over the formula for this last class, but we didn't actually do any problems with it. So let's just kind of, you're gonna probably should get out that pink circle, that pink sheet that we did after the quiz last time, where we had all those formulas on it. And if you look at number 3, do you remember what you do with the 81, the 41, and the x? Isn't that one of the formulas that we looked at on the formula sheet that we put together last class? Do you see it there? So you're going to say that the angle is equal to 1/2, and then since they cross in the middle, we're going to add them together. And it is the 2 arcs that they are intercepting, so it is these 2 arcs that happen to be named. Sometimes you'll be given another one as opposed to the 81, but this is the one that we're looking for. So it is going to be 41 plus 81. And so what I mean when I say show me your work is that I'm looking for this information along with an answer, okay? Don't just give me an answer, but show me how you got it. Fair enough? So there's all different kinds of information on here. You're going to have to subtract sometimes, you'll have to add sometimes, but we went over those formulas in class last time, so I want to make sure that you have those there, and that you're using that sheet, okay? And when we did define what a sector was just kind of like a slice of the circle. The sector does have a corner at the center, so this is circle C. And you'll notice something about a sector, that the outside edge is called an arc, and it has a length. Now, there's two things that we need to talk about in terms of this arc. It has, you can throw it right on my desk, love. It has a measure, a degree measure, and that degree measure is 45 degrees. But it also has a length, okay? And so there's two different kinds of measurements for there. Let's start with arc length, and then we'll get to the area. So on your note card, we're going to be taping these. I believe it's kind of a pale yellow color. I think it says area and circle properties in your SOL binder. Do you see it in there? And there should be like a slot for 3 note cards. Yeah, thank you, Jared. He's holding it up. And you'll see it has like 3 slots on the bottom there for us to tape note cards too, okay? So on the bottom, excuse me, of one of these note cards, since we're going to be taping them vertically like this, I want you to write arc length across the bottom of one of these note cards because that's what we're going to be doing first. And then on the bottom of the other one, we're going to be doing area. Okay, so we're going to be taping them vertically. I don't care if you orient it this way, but just like Ashley did there. Okay, although area of a segment's not what we're going to be doing. I know it says it on the thing, but it's erasable. Anyway, we have arc length. So if you notice that we want to think about, not notice, but we want to think about what is the length of that particular arc. Treat it like a piece of twine or a string. And if I went all the way around the circle, what is that called? The circumference of a circle. Good. So I know that I want part of the circumference. Do you agree? Not the entire circumference. I don't want to go all the way around the circle, but I just want this little part. And the part of the circumference I want is the length of AB. Are we in agreement that that's what we're doing? Just part of a circumference. So we need to remind ourselves that the circumference formula for a circle is 2 pi r. And that is something that's given to you. Sophia, just write it on my desk is fine. Thanks. It is something that's given to you on your SOL formula sheet, I believe. Can you guys flip to the front of your binders? Let's make sure. If you look underneath the circles, you'll see that C equals 2 pi r is written there. Okay? So it's not something that we need to memorize. It's the process by which we need to think about. So I know that the length of AB, part of it, we're going to take, it's the part of the circumference. Well, what is the circumference first? Let's figure it out. Well, it's 2 pi r. So 2 pi times 8. Do you agree with that part? That's the circumference of the entire circle would be 16 pi. And we can leave it in terms of pi, or you can multiply 16 times 3.14, or 16 times pi, and that's about 50.3. Okay? But I don't want 50.3. I know it's got to be smaller than that because I want part of it. Well, the way that we write part is it's the degree measure over 360. 360 is the entire circle. What degree measure are we concerned about? The 45 degrees. So this is how we would find the arc length. It's part of the circumference. So we're going to actually type it into our calculator, but we'll leave it in terms of pi. So that simply means that we're going to go ahead and say, in parentheses, 45 over 360 times 16, or times 2 times 8, or 2 pi, which is and it should be inches, because our units are just linear units. We're not talking about squared or cubed or anything. Now 2 pi is approximately 6.3. So that's our exact answer, and our approximate answer is 6.3 inches. Okay? So again, part of the circumference helps us find arc length. Okay, the length of a particular portion of the circumference of the circle. It's just part of it. And again, arc length is different from arc measure. What kind of units does an arc measure have? Degrees. Okay, and an arc length would have, in this case, inches, some kind of linear measurement. Now, what's going to be different about the area of the sector? Okay, so this is on your second note card, and again, you want to write area of the sector underneath or on the bottom. We're going to orient them vertically so we can tape them to our flip chart. And what do you think? We're going to use sort of the same process, part of something. How do you think we would set up to find the area of the shaded region, that area of that particular arc? What do you think we'd do? For arc length, we did part of the circumference. What are we going to do for area? A student say? Okay, we're going to actually look at that in a minute, and that's our next example where we have a triangle, okay, and we're going to look at that. But if you notice from what a student said, the triangle, does it have a larger area or a smaller area than the sector itself? The triangle would have a smaller area than the entire sector, okay? So we're going to look at that situation in just a minute. But let's first find just the area of the entire sector, okay? So the entire sector is going to be part of the entire area of the circle. Well, how do I figure out what the entire area of the circle would be? Well, using the formula, because the area of a circle is pi r squared, right? So pi r squared, or pi r squared. And how am I going to do the part? What part am I looking at again? Still 45 over 360, exactly. Okay. So still 45 over 360, but this time we're not going to multiply it by the circumference. We're going to multiply it times the area. Okay. So again, 45 over 360. And this time times 8 squared, or times 64. And remember, it's in terms of pi, so we have 8 pi. And that would be the exact answer. What kind of units am I looking at? Not just inches. Inches squared. We're talking about an area, right? So square inches. And what is that approximately? What is 8 pi approximately? 25.13 square inches. Okay, so that would be the area of the sector. Okay. All right, so on your third note card is going to be your third example, and it's actually when you have to do two different things. Okay, and so I know it says on your flip chart area of a segment, I think it says. Is that what it says? Which makes absolutely no sense because you can't have an area of a segment, right? But we're going to find the area of two different things. So you don't have to title it. You can just write area is fine. But we're going to find the area of the shaded region. In this case, the region looks different. So this is going to go on your third note card. Okay? So on your third note card. So first one we had arc length. Second one we had area of a sector. This one we're going to have just some random shaded region. So some random shaded region here. And I want us to find the length. Oh, well first, this is a totally different problem. The length of MC. Just real quick, you don't have to write this down, but the length of MC is a totally different problem. What would I do to find the arc length? Just real quick. What would I do? Go ahead, Jared. 90 over 360 times, because we're finding the length, not the measure. What am I missing? I'm not missing it. It's written in the problem. What's the radius? 5. So the length is going to be 2 pi r. Would you agree with that? Okay, that's just the process, but that's fine. We want to find the area. Again, you don't have to write the arc length down, just kind of a, oh yeah, by the way. What process do you think we need to find the area of the shaded region? Because there is a process. What do you think? It kind of goes back to what Astutse was saying a second ago. What about the triangle? And how Zara said that the triangle has a smaller area than the sector. How would I find just a little sliver of what I want? Astutse?
Find the area of the triangle and subtract it.
Find the area of the sector and the triangle and subtract it. I totally agree. So that's going to be our process. We're going to find the area of the sector minus the area of the triangle. And that will leave us with what the information that I need. So we're going to have to find two areas here. And so let's do that. Let's first find the area of the sector. Do that over here. How do I do that? What's the area of the sector? Carrington, how would I start that? How do I find the area of a sector? What's the area of a circle? What's the formula? Look at your notes. You just wrote it down in the area. Good. So I'm going to start with pi r squared, and instead of r, I'm going to write what? What's the radius here? 5, okay? And instead of the entire area, I want part of it. So what degree measure over 360 do I want? What degree measure am I looking at here? 90. Good, Ashley. Absolutely. And so that's going to be the area of the sector, or at least how we find it. So it's going to be 90 over 360 times 5 squared, or 6.25 pi. And we'll leave it exactly, so we won't multiply by pi yet. Okay, we'll leave our answer exact, and we'll see what we need to get here. How do I find the area of the triangle now? What is the area of the triangle? Can everyone look at the formula on your area of a triangle? Can everyone look at the formula sheet, that your SOL formula sheet for me? Look at that one. Your SOL formula sheet. Do you see under triangle that there should be 1/2 base times height, but I believe there's another one somewhere. It's on the back. Oh, there is no back. Ha. Okay, there is a back somewhere, but it should be 1/2 AB sine C. I don't see it on there. Okay, that's fine. We'll do that one. We'll do that one next class. So I see 1/2 base times height. So 1/2 base times height. What's the base? 5. That's a radius. What's the height? It's also 5 because it's also a radius. Wouldn't you agree? Okay, so we have 1/2 times 25, or 12.5. Yeah. So that would be the area of the triangle. So I'm going to have the triangle is minus 12.5. The area of the sector is 6.25 pi. That would be the exact answer. They're not like terms. You wouldn't be able to subtract them. But most likely you would be asked to give me a decimal answer in this case. And so approximately 7.13. And what units am I going to be using here? Centimeters. If you look at the problem, centimeters, right? So square centimeters. What, love? No, I went ahead and put the pi in just to get my final answer. So 6.25 pi minus 12.5 is that. Yeah. Why is the base pi? Because it's a radius. AC is a radius and AM is a radius. Because circle A. The hypotenuse is not the base or the height. We find the area of the triangle. It's just 1/2 base times height. And the base is a radius and the height was a radius in this particular case. Okay, good questions. Anything else? Yes, ma'am. Okay, so that's just like the portion of the triangle. 90, if you did 360 over 360, it would be 1. It would be the entire thing. So this portion right here, or this is kind of like the percent of, the proportion of the entire thing. So this just tells me 90 over 360 is a quarter, if you actually divided it, 0.25. That means that this is a quarter of the entire circle. Okay? So all that is a ratio, part over whole, that tells you what we're doing for the entire circle. Okay? So you take whatever degree measures you have for the angle and put it over 360, and that will give you the portion of the circle we're talking about. Okay, good questions. Anything else? Not too bad, right? All right, so I have some problems I want you guys to work on. So you can go ahead and tape these. I'll pass the tape around. Ali, can you grab the tape? It's right on my desk. You need 3 pieces of tape. Tape these in, and then once you have them taped, we're going to go ahead and put them inside of on the shelf, I mean. So I'm going to go ahead and pass these out. You have 13 of these problems. I'm only going to grade 1 through 10. 11, 12, and 13 will be extra credit. Okay? So 1 through 10 in the back, you're going to save. We're going to do this another day. Okay? So 1 through 10 right now, you do have a separate homework assignment out of the textbook. So keep that in the back of your mind. All right, so once you get 1 through 10 done, that's going to be your classwork. Okay? You're going to turn that in. And then your homework is going to be on page 663, 1 through 18 all.